So, welcome to coordinate plane geometry. We're just going to do a little bit of this, and today we're going to use it for quadrilaterals because these come up in the quadrilateral chain activity, but they work for isosceles and equilateral and many other geometry things. So, coordinate plane geometry means you're given coordinates for the vertices and you need to figure some stuff out. The things that can help you are the distance formula, which hopefully you will pause the video and write down from memory. Ready? Go. All right, hopefully you are looking and yours is the same as mine. And also, by the way, I accidentally wrote plus first and had to fix it. All right, do the same thing. Pause the video and write down the midpoint formula. Good, the midpoint is the average, so you just average the x's and average the y's. For the slope formula, you're going to use the slope formula to decide if lines are parallel and perpendicular. So just to review, the slope formula is m, remember that stands for slope, equals y minus y over x minus x. Be consistent. So if you use the first y first, then you need to use the first x first. And something you may or may not have learned is that the slope of parallel lines is the same. So if I gave you two lines and the slopes were the same, you would say those lines are parallel. For perpendicular, the slope is the opposite reciprocal. Oops, I can't spell. Opposite reciprocal. So for example, if I told you that the slope of a line was -1/2, then the slope of a line that's parallel to that would be -1/2. And the slope of a line that's perpendicular would be +2/1, or just +2. All right, now why would you need these? What are they going to help you with? Well, the distance formula can help you decide if the sides are congruent or not. The midpoint formula will help with diagonals, right? It'll help you decide if the diagonals are bisected at a certain point. If they have the same midpoint or halfway point, then they are probably bisected. And the slope will help you determine if lines or sides are parallel, but also if the diagonals are perpendicular or if the sides are perpendicular, forming a square or a rectangle. All right, so here we go. We're going to do two examples and then you should be okay. So we want to classify the quadrilateral by its vertices. We have a few different quadrilaterals with parallel sides, and we also have some with congruent sides. So let's go through finding the length of sides first. So we know we're going to need to find AB, BC, CD, and AD. Now, could you graph this? Of course you could, but you should still do this part to verify. Now, I'm going to kind of walk you through the way I do this quickly using the distance formula. So all of these are going to be distance formulas. We're checking lengths of sides. All right, and AB is x minus x. So 9 minus 8 is 1 squared, is 1, plus y minus y. -4 minus -2 is -4 plus 2, which is -2 squared is 4. So AB has a length, the square root of 5. Let's check BC. X minus x, 8 minus 2 is 6, squared is 36, plus y minus y. -2 minus -5 is the same as -2 plus 5, and that would be 3, squared is 9. So BC is the square root of 45. CD, 2 minus 3 is -1 squared is 1, plus -5 minus -7, -5 plus 7 is 2 squared, which is 4. So hey, we have at least one pair of congruent sides. And let's check A and D. 9 minus 3 is 6, squared is 36. -4 minus -7 is 3, plus or squared is 9, and that's the square root of 45. So this could be a parallelogram. It could be a rectangle. It could not be a trapezoid. It could, because it has too many congruent sides, it could not be a rectangle or a rhombus or a square, because they would all be the same. So we're kind of narrowing down between a parallelogram and a rectangle at this point. One thing you kind of need to know as a side note is that when you are looking at this, you need to kind of picture what it looks like on the coordinate plane. And when you name them, it has to go around the shape. So I am going to graph this little guy, just really a rough sketch so we can see, and then we'll go from there. So 9, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4. 8, -2, 2, -5, and 3, -7. All right, so we have A, B, C, D. So see how it kind of goes around? All right, again, that's a terrible drawing. We're not going to judge based on the drawing, but it gives you a visual. So we know for sure that AB is congruent to CD. All right. Hopefully you understand why I did that. Okay. So we're going to narrow this down between a parallelogram and a rectangle. So what are some things we could check? Well, we could check the length of the diagonals, because the diagonals themselves are congruent only in a rectangle. So I'm going to choose to do that, but I'll show you another method also. The diagonals would be DB and CA. Now, if these are congruent, then it has to be a rectangle, because a rectangle has congruent diagonals. So DB, 8 minus 3, oops, hold on, let me do my thing. 8 minus 3 is 5, squared is 25, plus -2 minus -7 is -2 plus 7, so 5 squared is 25. So the diagonal is the square root of 50. CA, 9 minus 2 is 7, squared is 49, plus -4 minus -5 would be 1, squared is 1. So it has congruent diagonals, so this is congruent diagonals. So it must be a rectangle. Now, it's a lot of work, right? But it's really not that terrible once you get used to it. Let's check one more thing just to kind of give you an idea of how that looks. Let's make sure that these are right angles. So if we look at CB, and we want to know the slope of CB. So the slope of CB is y minus y. So 8, or y minus y, -2 minus -5 is 3 over x minus x. 8 minus 2 is 6. So the slope of CB is positive 1/2. All right, the slope, let me get this how I want so you can see it. The slope of BA, y minus y, -4 minus -2 is going to be -2 over x minus x. 9 minus 8 is 1. So you can see that these are opposite reciprocals, 1/2 and -2 over 1. So this is actually a right angle. And if we did that all around, we would find they are all right angles, which also proves that it is a rectangle. Confusing a little bit? Absolutely. But can you do it? Yes. All right. Let me just kind of throw this out there. Another thing that we could do is to find the midpoint of the diagonals. And we would just do that by using the midpoint formula. Where do they intersect? Oh, at the midpoint, because in a parallelogram and rectangle, diagonals bisect each other. All right. In a square, JKLM, so I'm just going to draw a square. Beautiful, right? square JKLM. J is located at -2, 5. And K is located at 2, 2. We want to know the slope of this side. All right, so let's think about what that means and what we need to do. First, let's find the slope of JK. So the slope of JK is going to be y minus y over x minus x. So 5 minus 2 over -2 minus 2. So the slope of JK is 3 over -4. We want to know the slope of LK. Well, it's a square, so what kind of angle is this? A right angle. And in order for that to be a right angle, the slopes must be perpendicular, the segments. And we know that perpendicular slopes are opposite reciprocals. So if this is -3 over 4, then the opposite reciprocal is going to be 4 over 3. All right, and those are slopes, not distances. All right, I hope that gives you an idea where to start. It is complicated, but it's not that complicated. You have to practice it. I can give you more practice on this if you'd like. Just let me know. Bye.